Okay, let us now solve question number 28 from the practice sheet. Question number 28 says, from each corner of a square of side 4 centimeters, a quadrant of a circle of radius 1 centimeter is cut, and also a circle of diameter 2 centimeter is cut as shown in the given figure. Find the area of the remaining portion of the square. Okay, so let us draw the diagram first. Question number 28. There is a square like this. Okay, this seems to be a rectangle. Let me correct it and draw a square or a shape which almost looks like a square. So this is a square. Okay, this is the square ABCD, and in this square what we have done is we have removed 4 quadrants of circle like this. Okay, these 4 quadrants of circle we have cut this portion. Okay, what I have done is I have taken a piece of square. Okay, a piece of paper which is a square, and from that I have removed this portion. I have teared out this portion. Okay, like this also, and like this also. So what are they? They are the quadrants of a circle. Why they are quadrant? Because this angle is a 90 degree. This angle is a 90 degree. This angle is also a 90, and this angle is also 90 degrees. So I have removed these 4 quadrants of circles whose radius is given as, where is the radius? Radius is given as 1 centimeters. So this much length is 1 centimeter. Okay, all these quadrants are of radius 1 centimeter. Then what I have done is, and also a circle of diameter 2 centimeter is removed from the figure. So what I have done is I have removed a circle from the center whose diameter is 2 centimeter, that is the radius of this circle is 1 centimeter. I have removed this much portion also. So I need to calculate the area of the remaining portion. Now what is the remaining portion that we have? The remaining portion that we have is this much, this portion. This is our remaining portion. This is our remaining portion. So what we have done is we have removed these 4 quadrants, and we have removed this circle from the center, and we have this as the remaining portion, and we need to calculate the area of this remaining portion or the shaded portion. So what we can observe is there is a circle removed from the center, so we can calculate the area of this circle. We have 4 quadrants removed from the 4 corners, so we can calculate the area of this 4 corners for this 4 quadrants also. So I will say that area of shaded region is equals to area of square minus area of circle minus area of 4 quadrants. Okay, so try to understand what I have written. I have said that the area of the shaded region will be what? From the square, I have taken this square sheet, I have removed this part, this part, this part, and this part. So from the area of square I have deducted this 4 quadrants, and I have removed a circle from the center. So this is the circle that I have removed. So this much area will be known as the area of shaded region. Now what will be the area of shaded region? Area of square will be equals to, for that we need the side of the square. So the side of the square is given as 4 centimeters. This is the side of the square, it is 4 centimeters. So area of square will be 4 into 4, that is 4 square, minus area of circle. Area of this inner circle will be pi into 1 square, okay, pi into r square, that is pi r square. This is the area of circle, minus area of 4 quadrants. Now, how to calculate the area of this quadrant? This quadrant or this quadrant, they look like a sector of a circle. Quadrant is what? It is a sector of a circle with this center, and the radius of this circle is 1 centimeters, and the angles subtended by the two radii of the circle are 90 degrees. Okay, so we have 4 of such quadrants. So what I can do is, I will multiply the total area by 4 into area of each quadrant or area of each sector. Area of each sector will be equals to 90 into pi r square, that is 1 square upon 360, that is theta into pi r square upon 360. So this will give you the area of shaded region or the remaining portion, okay, in centimeter square. Please remember the unit also. So what you can see is, this question is not at all difficult, it's just a tricky. This kind of questions are known as tricky. These are not difficult question. The difficult question was question number 27. For that question I will say it's a bit difficult for solving. Why? Because there is a area of overlapping areas and you need to remove that area. You need to be cautious while solving that question, because the overlapping area may repeat again. Okay, so this question is very simple, it's a tricky question. So this is the solution for question number 28. Let us then solve question number 29. Question number 29 says, find the area of the shaded design in the given figure where ABCD is a square of side 10 centimeters and semicircles are drawn with each side of the square as diameter. Okay, so what it says is, question number 29, it says that in the given figure, let us first draw the given figure. This is the figure A, B, C and D. In this figure we have 4 semicircles drawn like this. We have 4 semicircles drawn in this manner. These are the 4 semicircles. Okay, these are the 4 semicircles that we have, and we need to calculate the area of the shaded region. Now what is the shaded region? This is the shaded region. Okay, so this is the shaded region. I need to calculate the area of this region. Now, how to calculate the area of this region? Let us understand this. What we can see is, all the 4 portions, all these 4 parts which looks like leaf, okay, which looks like leaf, are symmetrical, are similar, are same. They all are same. So if somehow I calculate area of any one leaf or any one portion of this figure, I will multiply that area by 4 to calculate the complete area, to get the complete area. So my task here is not to determine the complete area of these 4 leaves, rather my task is to determine the area of any one leaf. So my analysis, my approach will be such that I will try to deduce the area of any particular leaf. Let us say this leaf. First I will focus on this leaf, I will calculate the area of this leaf, and then only I will move further. So if we magnify this much portion, this AD is total 10 centimeters. This AD is given as 10 centimeters. So what will be the radius of this circle, this semicircle? The radius of this semicircle is equals to 5 centimeters. It is half of this, because this AD acts as the diameter of the circle. Then what about this AB? This AB is also 10 centimeters. Then what about this radius of this semicircle? The radius of this semicircle will also be 5 centimeters. So if I magnify only this much part, I will be able to observe that my figure is something like this. My figure is something like this, where this is A. Let us say this is a point. Let us name these points as P, this point as O, and this point as R. So this is point P, this is point O, and this is point R. Okay. Now I need to calculate the area of this region, where AP is equal to 5 centimeters. AR is also equals to 5 centimeter. Now by symmetry, this shape is also looks like a square. Okay, APOR, this is also a square. So I will say this is also 5 centimeter, this is also 5 centimeter. Now this angle is 90 degree. Why? Because I have drawn a line like this, which is perpendicular to the sides of the square. Okay, so this angle is 90, this angle is also 90. Now observe this, this particular figure has 3 regions. This particular figure has this as region 1, this as region 2, and this as region 3. Okay. Now what I will see, what I can see is this R is the center of this particular semicircle. This semicircle. This R is the center of this particular semicircle. So what I have done, I have taken only this much part. So this R will be the center of this arc, like this. R will be the center of this particular arc. Okay, this one. So what I can see is this part, this much part, only this much part. This is a sector. This much part is a sector of a circle, whose radius is equal to 5 centimeter. What I can say is ARO represents a sector of a circle with radius equals to 5 centimeter. This is one of the observation. Now what you can see is, if R is the center, RA and RO are the radii of this circle. Okay, RA and RO will act as the radii of this circle, and the angle between the radii of the circle is 90 degrees. So if I ask you what is the area of this sector ARO, I will say area of sector ARO is equals to theta into pi into r square upon 360 degrees. This will be known as the area of sector ARO, this region, this area. Okay. So now what does this sector represents? This sector represents the area, this sector represents area of region 1 and region 2. So sum of area of region 1 and region 2 will be equals to pi into 5 ka square divided by 4. This is calculated as 4. So this is the area of region 1 and region 2. Okay. Now if somehow I be able to determine the area of region 3? Can I determine the area of region 3? What I can see is APOR is a square. So, if I ask you what is the area of region 3, it will be equals to area of square minus area of sector ARO. Okay, area of region 3. Now try to understand why I am calculating the area of region 3. It's because if I get the area of this region or area of region 1, we will talk about area of region 3, or you can take area of region 1, both are similar. So if I somehow get the area of region 3, then I can consider this sector, I can consider APO sector and calculate the area of APO sector and remove this third region to get the area of second region. Our task is to calculate the area of second region. So first, for that I need area of either sector 3 or sector 1. So I am trying to determine the area of sector 3. Now from this formula, what will be the area of sector 3? Area of sector 3 will be equals to area of square, which is 5 square, minus area of sector is pi into 5 square upon 4. This is the area of region 3. Now I have the area of region 3. Now try to understand, try to observe the condition. If I calculate the area of sector APO. Now why I am saying that APO is a sector? Why it is so that APO forms a sector? It is because this P point acts as the center of this semicircle, this particular semicircle. Okay, this is the center of this particular semicircle. And what I have done, I have taken the arc of this semicircle up to from O to A only, like this, and this angle is 90 degree. So what I can say is, similar to this region as I have written, I can say that APO represents a sector of a circle with center, or sorry, with radius 5 centimeters. Okay, APO represents this sector. Now what I can see is area of sector APO is equals to area of region 2 plus region 3. Okay, area of sector APO is equal to area of region 2 plus region 3. So from this, can I write area of region 2 is equals to area of sector APO minus area of region 3. Okay, what I am doing is I am trying to calculate the area of region 2. So if from this complete sector, if from this sector I remove this much area, I remove region 3 area, I will be left with region 2. So what is the area of sector APO? Area of sector APO can be calculated very easily. Why? Because P is the center, PA and PO are the radii of this circle, and the angle between the two radii is equal to 90 degree. So we can very easily calculate the area of sector APO, which is 90 into pi into r square, that is 5 square, divided by 360 degrees. Okay, this is 360 degrees. So this will give you 1, this is 4, minus what is the area of region 3? It is 5 square minus pi into 5 square upon 4. So this will give you pi into 5 square upon 4 plus minus 5 square minus or plus, minus minus plus, it will give you 5 pi into 5 square upon 4. So what I am going to say is the area of region 2 is equals to 5 square common, okay, to the bracket pi by 2 minus 1. Okay, this is the area of region 2. If you solve this, you will get 5 square into pi by 2 minus 1. This is the area of region 2. Now region 2 is what? This is what I have mentioned as region 2. If I talk about all other 3 regions similar to region 2, so this region, this region, this region and this region all are same. So if I know the area of this region, what will be the area of this region? It will be same. What will be the area of this region? It will be same. And about this region, it will be same. So what I am saying is area of shaded region is equal to what? Area of shaded region is equal to 4 times 5 square to the bracket pi by 2 minus 1 centimeter square. Okay. Why 4 times? I have added these 4 values. I have added these 4 areas. So it will be 4 times 5 square pi by 2 minus 1 centimeter square. Okay. You need to solve this further. So what you can see is this question is very tricky as well as very complicated. It's because you need to think how to determine area of this second region. You may follow another approach, it do not matter, but what I am telling is the approach which is the easiest one, or I should say which is the smallest one. So how I have determined the region 2? First I have calculated the area of region 1 and region 2, the summation of area of region 1 and region 2. From that I have calculated the area of region 3. Then from that I have calculated the area of region 2. So how the cycle is going? First 1 plus 2, then 3 minus complete will give you region 2. इस तरह से हमने साइकिल में इस region 2 के एरिया को डिटरमाइन किया. So this is a very important question, very important question from the exam point of view. You can see this question, it's a lengthy question. It requires logic, it requires tricks, okay, and also it requires the calculation at the end. So this is the solution for question number 29. First note this, then we will continue. Okay, so now let us solve question number 30 from the practice sheet. Question number 30 says, in a circular table cover of radius 32 centimeters, a design is formed leaving an equilateral triangle ABC in the middle as shown in the figure. Find the area of the design. So what question says is, question number 30, it says that there is a circular table cover. Okay, you know what is table cover. So on this circular table cover, what I have is, I have a design made such that there is an equilateral triangle like this, and after this portion has some design. So this portion is designed. This is the complete round table mat or round table cover we can say, and this is a triangle which is ABC triangle. Leaving this much portion, the rest of the circular table cover is designed in some way. I need to calculate the area of design. Our task is to calculate area of design. Now, how will I calculate the area of the design? The first thing that should be noted is that ABC is an equilateral triangle. It means AB is equals to BC is equals to AC. Now, what is AB? AB is a chord of circle. BC is also a chord of circle and AC is also a chord of circle. Since the 3 chords of this circle are equal, the 3 chords of this circle AB, AC and BC are equal. It means since AB, BC and AC chords are equal, therefore the area enclosed by them with the circle, the area enclosed by them with the circle is also equal. So what I mean to say is that since AB, BC and AC are equal, these three areas, this is area 1, this is area 2 and this is area 3, these three areas are also equal in value. The three areas are symmetrical, they are equal. Okay. So if I calculate the area of one portion, that is, if I calculate the area of region 1, I can calculate the area of region 2 and 3 also, because they are same. So what I'm saying is, area of region 1 is equals to area of region 2 is equals to area of region 3. So these three regions are equal in area. Then if I assume that O is the center of this circle, O is the center of this circle, and if I join OA, this is OA, this is OB and this is OC. OA, OB and OC are the radius of this circle. OA, OB and OC are radii. Now, is the radius given? Yes, radius is given as 32. So any of these value is equal to a 32. Okay. Now, one more important thing, since the chords are equal in length, the three chords are equal in length, then if I talk about angle subtended by chord AC at the center, angle subtended by chord AC at the center is, let us say, theta. Similarly, angle subtended by chord AB at the center is again will be theta. Why? Because equal chords subtend equal angles at the center. This is a property of the circle. Okay. Similarly, angle subtended by BC chord at the center is also theta. So what I want to say is, angle AOC is equals to angle AOB is equals to angle BOC. Why? Because equal chords subtend equal angles equal angles at center. Okay. So it means theta plus theta plus theta is equals to 360 degrees. So theta plus theta plus theta is 360, because these three thetas contribute to a make a complete angle. So the value of theta is equals to 120 degrees. This is the value of theta. So if you consider any particular, if you consider, let us say, these two radii, B, OB and OC. So what I can see is OB and this C is a sector, OBC is a sector, or let us say name this as P. So OBPC is what? It is a sector, OBPC. Now OBPC is a sector and I can see BPC, this region is the segment or also known as the region 2. So what I can write is, area of region 2 is equal to area of segment BPC. Area of segment BPC, where what is the area of segment BPC? It is equal to area of sector OBPC minus area of triangle OBC. This is what we know about the segment. We have calculated the area of segment many times. So this segment will be equals to area of this complete sector minus area of this triangle. Now area of sector, angle is, the angle subtended by the two radii is 120 degree. So area of sector will be 120 into pi into radius is 32 square upon 360 minus, what is the triangle OBC? This is the triangle OBC. What is the radius OB? It is 32 centimeters. So area of triangle OBC is half r square sin theta. So half r square is 32 square into sine of angle 120 degrees. This angle is 120. Okay. Now we have calculated value of sine 120 many times. Sine 120 degree is equal to sine of angle 90 plus 30, which is equals to cos 30 degree, and cos 30 degree is equals to root 3 by 2. This is, we have calculated many times. So solving this, it will be pi, or I should take 32 square as common to the bracket. I will be left with pi by 3 minus, this will be root 3 by 2. So root 3 by 4, because we have half here also. So this is the area of region 2. Now if I calculated the area of region 2, what is the area of region 3? It will be same. What is the area of region 1? It will again be same. So I will say that total area of design is equals to area of region 1 plus area of region 2 plus area of region 3, that is 3 times 32 square to the bracket pi by 3 minus root 3 by 4. This will be the area of total design. Total area of design in centimeter square. Okay, in centimeter square, this is the most important. So what you can see, this question is not at all difficult. Only the thing is you need to analyze how you have to apply the area of sector and area of segment. In most of the question in this chapter, you have seen that we have applied either area of sector, either area of segment, or both, and some properties of circles and properties of squares and parallelograms. So for this chapter, to understand this chapter, you need to solve a lot of questions related to this chapter, so that you can apply different properties, you can see different kind of numericals from this chapter, and then only you will grasp the concept. Because if I talk about this chapter alone, this contains only two concepts, that is the sector and the segment. But what is required is the previous properties of circles and parallelograms and triangles that you have studied in 9th class as well as in the 10th class in triangles and circles. Okay. So this completes question number 30. Okay, first you note this, then we will continue.